Good morning. So here I'm going to explain Unit 4 in digital image processing, that is image restoration and image segmentation. So here this unit involves two important processing steps in digital image processing. One is the restoration, another one is segmentation. So under the restoration we have degradation model, inverse filtering, list mean square filters, constraint least square restoration, blind deconvolution topics. Under segmentation we have edge based segmentation, threshold based segmentation, region based segmentation, template matching, use of motion in segmentation. So now here the first one, image restoration. So here of course we know the definition of restoration and what is the differences between restoration and segmentation discussed in chapter 1 as well as in chapter 3 also. So here image restoration is nothing but to restore a degraded image back to the original image. And of course image enhancement is to manipulate the image so that it is suitable for a specific application, right? So now here the image restoration block diagram is here. So here one image is there that is degraded. One image is there that is degraded. So let it be g of x comma y. So the degraded image is applied to the one system. Here that system is called as restoration filter. So this restoration filter or the system converts this degraded image into the proper or desired output image. So here this f cap of x comma y resembles the actual original image, but you don't know the original image how it is, but user should satisfy with this what is that output image. So that means he knows the he knows the output image how it should be. So now to get that particular desired image, we should apply the restoration technique to this degraded image. So here restoration filter is nothing but restoration filter or image restoration technique or system is nothing but it completely depends on the degradation function. So that means here degraded image is degraded by the certain things, that is nothing but here degraded function and noise. So okay, here based on this degraded function and noise, then only we should develop the restoration filter, then you can get the proper output image. So actual block diagram is this one. Actual block diagram is this is input image, that is a degraded image, and this is the output image, that should be the estimated image. That should be the estimated image or exact or original image, replica of the original image. So now here input image or degraded image is here to the restoration filter. How it is degraded based on two factors. One is the noise, another one is the degraded function. So okay, here observe this is one more block diagram which is attached to this one. So that means which gives the information to us on what basis g of x comma y is obtained. So that means here one input image is there, that is degraded by this degraded function h. Then certain noise is added to that particular image, then you can get this g of x comma y. So okay, now here consider what is the g of x comma y, what is the degraded image. So now here see this g of x comma y is what is the output of this degraded function. So here input is f of x comma y, degraded function is represented as h of x comma y. Now how can you get the output? By convolving these two in the spatial domain. If you consider frequency domain, just multiply these two, then you can get the frequency domain representation of that image. So now here in the spatial domain, the output is nothing but here f of x comma y convolved with h of x comma y. That is added to this noise function that is represented as n of x comma y. Now this degraded image g of x comma y is denoted as f of x comma y convolved with h of x comma y plus n of x comma y. So okay, right? So now based on actually this g of x comma y internally depends on h of x comma y and n of x comma y and of course f of x comma y. So here by taking restoration filter, you should extract the f of x comma y from this g of x comma y. Okay, here if you apply that means this one is in a spatial domain. So if I take this one in terms of frequency domain, g of u comma v is nothing but multiplication between f of u comma v and h of u comma v plus n of u comma v. So that is g of u comma v is equal to f of u comma v into h of u comma v plus n of u comma v. So now here, so noise means here our degraded image is affected by the noise also, right? How can you estimate this noise? To remove the noise from this degraded image, we should know about what type of noises are added to the image, right? So that's why here we should concentrate on noise models here. So here probability density functions PDF is given here for different noises. So the first one is a Gaussian noise is there, Rayleigh noise is there, gamma noise is there, exponential noise, uniform noise, salt and pepper or impulse noise. Different noises are there. So there's a PDF also given here. So now first one is a Gaussian noise. That mathematical representation is 1 by 2 by sigma e power minus z minus mu whole square by 2 sigma square. And the representation is like this, right? This one. So if noise nature is like this, so then that is said to be Gaussian noise. So now this one is for Rayleigh noise and this one is for gamma noise, exponential noise. This one is uniform noise, this one is impulse noise or salt and pepper noise. So these are the equations for each noise. These are the equations, right? So now here, how can you avoid this noise? Actually, suppose if there is a one noise, how can you avoid? Suppose here there is no degraded function. So h is here 0. That means f of x comma y is not degraded by any degraded function. Now it is directly goes to this one. Now that adds to the noise. And then g of x comma y is nothing but simply f of x comma y plus noise n of x comma y. Now if you consider only noise, how can you remove that noise? Based on the enhancement techniques, we can remove that noise, right? So no confusion here. Now restoration filters are nothing but enhancement techniques. So based on the enhancement techniques, we may remove the noise. So that means here we have the different methods in enhancement techniques. Based on that, we can easily remove the noise. So here say this here mean filters. So to remove this part, right? To remove or reduce this part here. So we have the different mean filters. So here smoothing means, what is the smoothing? Image smoothing in enhancement technique. To reduce the noise, we are using the smoothing techniques, right? So okay, all smoothing techniques are applicable here to reduce the noise. So maybe mean filters, averaging filters. In that we have different filters. So one is the mean filter, arithmetic mean filter or moving average filter, geometric mean filter. So here the representation mathematical equations are given here. So here due to this harmonic and contra harmonic filters, So one is suitable for specific noise reduction, right? So here, based on this image smoothing techniques like mean filters, so lot of mean filters are there. By using that one, we can reduce the noise. So okay, right? So now restoration filter is here easily enhancement technique, enhancement techniques, right? So okay, now in the same way here, so okay, here you see this order statistics filters also there. So order statistics filters means median, minimum, maximum filters like that. So midpoint filters, right? So many filters are there to reduce the noise. So here, of course, this is nothing but a review. So generally, if you know the enhancement technique, that means the mean, median, minimum, maximum filters in the image smoothing or image enhancement techniques, we can easily remove the noise in the particular image, right? So now, so we don't have the bother about the particular noise here, right? So now, but what is the problem? Image degradation. That means here one degraded image is there. Due to the degraded function, our input image is degraded. So how can you estimate that degradation function? So if you know the particular degraded function, then only based on that you can find out the restoration filter easily. Then by applying that restoration filter on the degraded image, based on the degradation function, then you can get the output image that is the exact replica of the input image or expected image. So that means here to estimate the degraded function, we should know about the h of x comma y, h of u comma v. In what way our image is degraded. Right? So here to estimate the degradation model or a function, here we have the three methods. Right? Three methods. One is the estimation by image observation, estimation by experiment, estimation by modeling. So this one is estimation by image observation. So that means here original image is this one, f of x comma y. But when I capture the image, this image, so I am getting this type of image. See this. This is the image. So when I capture the image, so here I get the output image like this one. So but if I observe this one, oh, this one is not the good image. User or observer easily conclude this one, right? Easily what is that? Easily identify this one, right? So what is that? This one is not the good image. This is something, there is a certain problem, right? So here this is here degraded image. So I don't know this image actually, but I am expecting this one, right? So that I am expecting this one. So that means here in space on camera is there for the system, that means a satellite. So here the satellite captures this image. So here that satellite sends this image actually. But here here in this particularly on the earth, people observing the particular picture, that particular satellite send the particular image. So here the user is on earth. So he is observing that picture, but so here is a one image. So user knows that this is not the correct image, right? So here user should convert or should restore from this degraded image to get the expected image. But if you don't know, this one is the exact one. But by applying some techniques, he can get the original image. Okay.